All right, let's dive right in. Welcome to your ultimate high-depth study guide for data analytics and visualization, Module 3. If you're a focused learner trying to completely master the intricate workings of text analytics, you are in the exact right place. We are going to unpack everything you need to know directly from the source material, ensuring you don't miss a single detail for your exam.
Here's our syllabus for this explainer. We're tracking the history of text mining, breaking down the 7 practice areas, unpacking the math behind information retrieval and fake news, parsing through technical NLP, and finally, putting you to the test with an exam simulator. Let's get to it.
Section 1. History of Text Mining.
Before we can really grasp how modern algorithms process human language, we have to look back at how we've tried to organize text over the centuries. It didn't start with computers. It actually started way back in the 1200s with manual origins, monks literally spending lifetimes manually creating concordances for the Bible. Fast forward through a few early mechanical eras, making up 6 distinct eras in total, to the 1950s, and we hit early computational linguistics. This era was all about syntax, grammar rules, and early machine translation. Think of it like trying to teach a massive computer to translate English to Russian using strict rules. Then the 1970s brought the information retrieval era, driven by the growth of digital documents. That gave us early search engines and concepts like TF-IDF for measuring term importance. Finally, the 1990s triggered the web and data explosion. The absolute sheer scale of the internet meant we had to shift from rule-based systems to data-driven models, which eventually led to the advanced transformers we rely on today.
Think about that incredible transition for a second. We went from enormous physical card catalogs, literally the epitome of manual indexing, all the way to the retro Archie query form from the 1990s. Sure, Archie looks completely primitive to us now, but that query form was basically the big bang for internet-scale data.
Section 2, the 7 practice areas. This right here is essentially your blueprint for text analytics. It maps out the specific methodologies you absolutely need to memorize. Now, out of these 7 core areas, you really must be able to distinguish between items 2 and 3 for the exam. Document clustering groups documents using unsupervised learning, meaning the model finds hidden patterns entirely on its own without any predefined labels. On the flip side, document classification categorizes documents using supervised learning. That means it relies heavily on models trained on explicitly labeled examples. That distinction is a classic exam focal point, so keep it in mind. The rest of the list rounds out with search and information retrieval, web mining, information extraction, natural language processing for low-level understanding, and finally, concept extraction. Section 3, information retrieval and classification logic. Now that we know the broad areas, let's zoom in on the applied mechanics. How do systems actually retrieve information? Well, information retrieval, or IR, doesn't just do a simple exact word match. It retrieves the most relevant results from a massive collection using a strict 5-step process. First, document collection gathers the raw data. Second, query input captures what you're actually searching for. Third is indexing the text for speed. Fourth is ranking the documents based on relevance. And fifth is the actual retrieval of those results back to you. But wait, before a system can index or rank anything, it has to clean the text up. Imagine a real-world Google search query. The text undergoes a rigorous pre-processing workflow. First, lowercasing standardizes everything. Next, stop word removal strips out the common, unhelpful words like the or and. Finally, tokenization splits the remaining text into individual terms. So, a raw document 1 turns into the pre-processed tokens data, mining, techniques. Along with processes like stemming and limitation, which just reduce words down to their root forms, this highly structured data is what the search engine actually uses. Document 2 maps to data analysis methods, and document 3 maps to machine learning techniques. Okay, so what about classification? How do we teach a computer to categorize a document as sports versus politics? We use feature extraction to convert text into numerical form, often called a bag of words matrix. Let's say document 1 contains the words team, wins, and match. It gets a 1 in those specific columns, and the document is labeled as the sports class. Document 3 contains election and results, so it gets a 1 in those respective columns and is labeled politics. By converting words into these simple binary features, algorithms like Naive Bayes or support vector machines can mathematically compute the probability of a document belonging to a specific class. Pretty cool, right?
Section 4, Web Mining Fake News Pipeline.
We're shifting from basic classification to the multivariable math used at an internet scale to detect fake news.
In this detection pipeline, step 5 is link analysis, which uses PageRank algorithms. This is all about who is linking to whom. If a page is being linked to by trusted sites and government portals, that's great. But what about an article mostly being linked to by random, unknown blogs? The algorithm views this interconnectivity, or the lack of it, as a massive signal. A page linked mostly by unknown sources is immediately flagged as highly suspicious. And that leads us directly into step 6, the source credibility score. The system asks one absolutely critical question. How trustworthy is the website that published the news in the first place? If it's from an established, verified publisher, it gets a high credibility score. But if it's from a low credibility source, even if the text content looks completely normal on the surface, if the publishing source has a history of publishing falsehoods, its overall credibility score completely tanks. So, how does it all come together? Step 7 is the final ranking, and the exact formula is super straightforward. Final score equals the content score, plus the link score, plus the credibility score. Look at page 2 in our example. It has a low content score, low link quality from those unknown blogs, and low publisher credibility. Sum those up, and the page is mathematically classified as fake news and pushed straight to the bottom of the rankings. It's a highly structured approach, and it's actually completely different from how algorithms parse mixed emotions in a single restaurant or smartphone review using sentiment analysis.
Section 5, Technical NLP and Parsing.
Now we're going to dive deep into natural language processing, or NLP, to uncover the low-level tasks required to actually teach computers human grammar. Before a computer can understand meaning, it literally has to break the text apart. We call this tokenization. We take a raw sentence like "I love data science" and slice it into individual processable words, or tokens. Our output becomes a clean array, "I love data science." It's the absolute foundational first step of any natural language pipeline. Once it's tokenized, the machine needs to know what role each word plays. Enter POS tagging, or part-of-speech tagging. This assigns explicit grammatical labels to every single token. Take the sentence, "The cat eats fish." The is assigned the tag DT for determiner. Cat gets NN for noun. Eats becomes VB for verb, and fish is another NN noun. The computer obviously doesn't intuitively know what a furry cat is, but it now mathematically knows the word is acting as a noun in this sequence. And here is where the logic really locks in: parsing. Parsing takes those POS tags and connects them into a structured syntax tree that a machine can structurally understand. The formula here is S, the sentence, equals NP, the noun phrase, plus VP, the verb phrase. It maps the sentence logic perfectly. The cat is the subject, eats is the action, and fish is the object. By converting messy human language into this rigid mathematical tree, the computer achieves true structural comprehension. Section 6. Exam Simulator. Okay, we have covered a massive amount of ground today. Let's turn the tables. It's time to activate your memory and test you directly on the logic flows we just covered to make sure you are totally exam ready. Question 1. Think back to our fake news detection pipeline. According to that web mining model, what are the 3 specific variables that are summed together to calculate the final rank of a web page? Take a second. Got it? It's the content score plus the link score plus the credibility score. If you remembered all 3 of those, you are in spectacular shape. Last question to really lock in your retention. In our technical NLP section, when we performed part-of-speech tagging on the sentence, "The cat eats fish," what explicit grammatical label was assigned to the word cat? The answer is NN, which stands for noun. We've tackled 2 key questions today, but for your exam, make sure you can also answer things like how abstractive summarization differs from extractive summarization, or how one single document can actually contain multiple conflicting sentiments. If a machine can learn to break human language into logical math, you can absolutely parse these concepts for your exam. So the next time you type a search query, ask yourself, what invisible pipeline is deciding what's truth and what's just noise? Keep exploring, and you're going to ace this.